do that. Okay. Hi, welcome to Zenninghams. Okay. 400,000 years later, we've evolved to the point where the choice of building materials is almost limitless and can be sourced from the other side of the planet if we desire. We asked our speakers to consider how they approach materiality in their design process and what it expresses about program, place, culture, and more. I want to thank the rest of our spring lecture series team, Dave Lennox and Padma Kudipudi from the University Architects Office, as well as John Barton and Jeffrey Tuttle from the Stanford Architectural Design Program. I'd also like to thank the AIA Santa Clara Valley chapter for their help in advertising the series and registering our program for continuing education. Please sign the sheet by the front door if you've not done so already. I want to make sure you get your CE credits. And lastly, I want to thank Carol Vertuccio and Jocelyn Gray from the Knight Hennessy Scholars for sharing this beautiful building with us tonight. We all have special access for just this lecture. The others go back to ChemH. So thank you for hosting us tonight. Our next lecture is in 2 weeks. We're going to have Ted Flato from Lake Flato Architects, and that will be back at the ChemH Neuro Rotunda. Now, it is my pleasure to introduce Meejin Yoon. J. Meejin Yoon is the Gail and Ira Druckier Dean of the College of Architecture, Art and Planning at Cornell University and co-founding partner of Höweler+Yoon. An architect, designer, and educator, Yoon is committed to advancing creative and critical practices and pedagogies, scholarship, and research that address the many urgent environmental and social challenges we face in our cities and communities. Yoon's own work and research examines intersections between architecture, urbanism, technology, and the public realm. Her professional projects include cultural buildings and public spaces, including the Institute of Democracy and the Memorial to Enslaved Laborers at the University of Virginia, the MIT Museum at the Massachusetts Institute of Technology, and the Living Village at the Yale Divinity School. Yoon received a Bachelor of Architecture from Cornell University in 1995 and a Master of Architecture in Urban Design from Harvard University Graduate School of Design in 1997. Her recent honors include the 2022 World Cultural Council Leonardo da Vinci World Award of Arts, and in 2021, she was elected to the American Academy of Arts and Letters in the field of architecture, the highest recognition of artistic merit in the United States. And now, please give a warm welcome to Meejin Yoon.
Thank you so much. It's such a beautiful building. Okay, I'm going to put this on. Great. So thank you so much for being here. It really is an honor to speak in this series. Thank you, Zach, for that introduction. I'm going to start with this question. What's the matter? What's the matter is a way of, I think, taking stock of the moment. In doing so, it asks not only what's the matter, but what matters and how do we as architects build, create, and enable what matters. So if we survey the present, we find ourselves at a moment where everything we had been taught about social distancing and the pandemic has shifted. We're in person, yet we're also hybrid and remote, and we're having to relearn what it means to be social. Pre-pandemic, we were already experiencing a saturation of technologies in the public realm. Every interaction and encounter was already mediated. And we live in a planetary and interconnected age, a moment characterized by both a superabundance of information and connectivity, and at the same time, an unprecedented amount of uncertainty. If this moment were not so fraught, we might say it's ironic that the age of information coincides with the age of post-truth. Today, we feel politically more and more divided, and we've collectively witnessed the fragility of our institutions, the fragility of democracy, alongside the resiliency of violence and hate. We've also seen the erosion of women's rights nationally and human rights internationally. And in this, deep social, economic, and political set of questions of our time, we're also in the midst of a climate catastrophe. So the planet is so fragile and vulnerable. It's burning quite literally, and especially you are all aware in this area. So what can we as designers do amidst these daunting layered challenges? I think of architects as stewards of the built environment. And so we're asking ourselves as architects, how do we have agency? How do we collectively take action to build a better world? So this is Charles and Ray Eames, and they were once asked to define design. And Charles responded in a Q&A when asked, is design an expression of art? He responded, no, it's an expression of purpose. When asked if design was a method of expression, he actually responded, no, it's a method of action. And when asked, what are the boundaries of design? He asked back, what are the boundaries of problems? So purpose, action, problems, and we have a lot of problems. So this is the kind of multi-layered, complex context, maybe often referred to as our contemporary wicked problems. So how can we reimagine architecture, both in education and practice, to prepare us for the future world? And so I'm going to use this lens of purpose, action, and problems to begin to think through this. So materials, right? We know architecture is highly material intensive and labor intensive. And if you look at the kind of material spectrum, and you think of the kind of volume of materials consumed, concrete is the second most consumed substance on Earth after water. It's also the most environmentally problematic of our building materials, but nothing has been able to replace concrete for foundations and other forms of construction. We had an opportunity to think about renewable materials recently. I love this kind of incredible photo of this giant tree, but also thinking of the industrialization of the kind of manufacturing of materials in the built environment. If you look at all the materials that we have available for construction, timber is actually the only renewable and sustainable material, especially with sustainable forestry practices. So we were asked to do a small installation at a site in Spokane, Washington. And one of the interesting things about this riverfront park was that it was the site of the World Expo in '74. And it was the first World Expo that really put forward the kind of environmental awareness that was, emerging in the late '60s and '70s. So our project was simply to create a pavilion of sorts, interactive sculpture, and we used it as an opportunity to learn about mass timber. When we think about mass timber, we think about CLT and the kind of industrial process of making cross-laminated timber panels, et cetera. But we really wanted to deal with the mass of mass timber. So here you can see kind of woodworking kind of history and legacy of the Pacific Northwest, and kind of contemporary manufacturing with timber through these much more industrialized processes where things are in sheets. So we were thinking, like, where is the form, or what are the possibilities of the form of the mass timber? thinking of it both from a kind of analog perspective as well as from a kind of robotic perspective. And we designed a pavilion that could be simply a place to shelter one in public space that you would sit within and then get a view of this beautiful park. The screws are 23 inches long that go between the essentially glue laminated timber. And this is the structure, and we're testing like the kind of cantilever capacities of the wood, and also exploring the real kind of beautiful qualities of the wood, like the checking, the things that everyone's always worried about, embracing that aspect of the wood. And so this just opened like 3 days ago, and so was there and enjoying watching people climbing the project. So we've been thinking about kind of materials in terms of the kind of embodied carbon, right? So materials as a kind of carbon sink. And so if there's a focus now really on embodied energy, I would say we're coming out of a legacy that has been very focused on operational energy. So this is also a pavilion in a park, but a much more urban park. It is located in Shenzhen, which is a very hot, arid climate. So you can see LA, Shenzhen, and Phoenix. And one of the ways that we wanted to create a kind of public space and public amenity in this very hot urban context is by creating shade. So the concept of the project, because they wanted the pavilion structure to be very glassy in order to have transparency, so people were not afraid of using it, essentially a glass box. We decided that we would basically create this big shaded roof that would shade the glass box program. But in looking at how to self-shade this building, one of the things we wanted to explore was, how do we design these louvers? One of our precedents was this beautiful building by FISAC, the Hydrographic Studies Center in Madrid, with these kind of incredibly shaped louvers that really control light and bring in a kind of diffuse light while blocking heat. So this is a set of studies where we're looking for a geometry that will maximize the amount of diffuse light and minimize the amount of direct light, so we can have as much light as possible without the heat. So through those studies, we developed a kind of custom profile, which is in the lower right-hand corner, and then had a custom extrusion made. So what I'm showing is the mistake. Like, this is the first extrusion, which totally wrong. But then they eventually got the extrusion right. And so this is the section of that extrusion. So those custom extrusions are positioned to create shade. And then really do create this kind of shaded outdoor space and a self-shading indoor pavilion. And then this is kind of the analysis of the kind of before condition, if this pavilion or this structure had not had the shade, versus the after, and really well used both outdoors and indoors now. And I love that, like, the best form of shade is actually the tree itself. So we made room to grow large trees through the canopy to contribute to that shading. So, you know, in the discipline of architecture, you know, we talk a lot about sustainability. And we had an opportunity recently to work with Yale University on an incredible project because it's a Living Building Challenge project. So a Living Building Challenge takes the normative elements that you would think about sustainability in terms of materials and energy and water, but it also adds these additional criteria of equity and beauty and placemaking, which is a much more holistic approach to thinking about sustainability. So before we would think only about the kind of negative environmental impacts and mitigating those negative environmental impacts. That was our definition of sustainability. But I think now beyond net zero, we're really thinking about net positive, thinking about restoring our environment. How can we build in a way that is much more restorative? And so one of the things we've been thinking about as a practice is not only building arts and building science, but building equity into that circular relationship and synthetic relationship to architecture. I think this kind of Living Building Challenge commitment, I think there are not that many projects that are able to meet those criteria. But it was amazing to have the opportunity to work with Yale, which prioritized this Living Building Challenge of building equity and having additional criteria to just net zero. The project is the creation of additional residential units for the Divinity School. It's a very historic campus, the Divinity School, and our addition is this U-shaped residence hall. But part of the design was really maximizing the solar production, and so that informed the geometry of the roof. Also, thinking about rainwater collection and its efficiency and treating the water on site. And then, of course, using cross-laminated timber as a sustainable material, and really thinking about the envelope enclosure to maximize the performance of the building. So we're able to reduce the total energy consumption by 70%. And this shares the kind of wall assembly of the exterior volume and the kind of early tests in summer and winter of this louvered system on the building. And that's our first mock-up, and we'll be starting construction just in a few months. The other thing we really worked hard to do is actually audit our own materials and think about our material selection as being extremely local to the maximum extent possible. And so just mapping where our materials are coming from. So that's on a kind of campus scale. Also thinking about restorative architecture at a much more urban scale. In 2010, there was a large expo in Shanghai, and it was on the periphery of the kind of center of Shanghai in a formerly industrial area. And this expo had giant pavilions. It's a Heatherwick pavilion on the right. And this expo took a lot of expenditure. Many architects built structures that would last all of a few months. And then the expo was over, and this industrial site was littered with these mega architectural pavilions. It's taken a while, but just 2 years ago, there's a plan to restore this whole industrial site and turn it into a park that would actually bring trees and landscape and water and be like similar to Central Park for the Shanghai urban area. So we were asked to compete in a competition for those two little red bridges as part of this giant park. But we are the entry to this park. And, you know, one of the things we thought about was the kind of difference in how we think about a bridge. If you think about a bridge infrastructurally, it needs to connect point A and point B. But here in the Chinese garden, the infrastructure, the bridge is part of the landscape, and it meanders and it frames and it creates views. And it's not the most efficient way to get from point A to point B. So, you know, there are two bridges. They needed to allow for ambulances to drive, but they were primarily pedestrian. And we thought instead of two bridges, what we should really do is make one plaza with a big hole cut out of it for the water. So instead of being a bridge that's long, it's actually a bridge that's very wide and a public space. The idea was that we would take this concept of like the moon gate, which kind of frames a view beyond, and use this figure of the almost circle to actually frame the water, which reflects the sky. We won the competition. They built this bridge during the pandemic. So this is a photograph. And on one hand, it's interesting to see the scale of it, but so disappointing that there's no people on this bridge. But it was during the lockdowns where you couldn't even walk in this incredible newly constructed park. But since then, things have changed and there's a lot more, of course, activity. This gives you a sense of that kind of scale and that industrial landscape where they've removed many of the giant architectural pavilions. The real infrastructural bridge on the right, the geometry of the bridge has a kind of double curvature that really kind of softens the way the water and the light reflect off the underbelly of the bridge and give it a kind of lightness. And then it has these little snouts, which are these balconies that allow you not to cross the bridge, but to take a pause and peer out and be really part of that landscape. And this is from one bridge to the other bridge. And one of the things we often do is really think of the material context of what makes the architecture. So we use local granite here. And then this is us in our studio really testing the scale by printing out full scale drawings to understand like the ergonomics and the tactility and the human scale of all of these projects. This is one of my favorite photographs of the project. I also think when you build with materials, you have to really think both globally and locally simultaneously. As Zach was saying, like we can now build anything anywhere from any material, and you know, other than the supply chain challenges of the pandemic, truly you could source material anywhere and everywhere, but that sourcing comes with a energy footprint, both in the manufacturing of the material, but then the shipping, etc. This is a project in Chengdu, China, where we work with really local materials and local trades. So this is made out of Chinese brick. And the idea was just a courtyard house packed together that would allow light deep into a very fat footprint because it's an exhibition hall, and then ways to cellularly break that down. The windows were pretty small and operable, and so we needed to create these giant window surrounds to mediate the scale. But I think what's interesting is people often say like, oh, did it rain? Why is the brick darker at the top? Was that designed? And this was not designed. It's just the natural output of the making of these bricks over the time span of constructing the brick. And so over that time, the brick manufacturing just got darker. And so you're seeing the kind of darker color bricks at the time. It's kind of an accident, which is quite lovely about the material imprint that a building holds and carries. The other thing we thought is we designed these surrounds as wood. And then we were told wood is extraordinarily expensive in this region. Could you change the material to coarse 10 steel, which self-protects, and we did. So that there are these lessons where you learn that something very sustainable in one context is not sustainable in another context. And then we were very excited to work with the local masons and the local brick, which is this kind of cool gray brick. And one of the things we thought of was, could we give the brick a rule, like an orientation? So all bricks have to face true east-west or north-south. And then on the oblique angles of the building, they still face true north, south, and east-west, which gives it a feathering texture. And this came out of just wanting a very simple rule, as opposed to drawing a million drawings, that it would just be like a simple rule that all bricks face east-west or north-south, no matter what the geometry is. So on the oblique angles, you get this incredible texture. When two angles come together, it looks like this. And then on like a long facade, you get this texture on anything oblique in the building. We've been thinking a lot about the city. I think we all have, because the pandemic really exposed the fragility of our cities. So we are practicing in Boston. And the interesting thing about Boston is it's a highly constructed city. So the project I'm going to share is in this cute little neighborhood called Bay Village, which is a historic district very close to that large open area, which is the Boston Commons and Boston Gardens. If you look at Boston, though, everything blue is infill. It's like artificial land, Boston itself, had it not filled in the land, would be just a tiny, almost island connected by a tail. So this building sits between what is called the high spine of Boston and this cute, tiny Bay Village, where the buildings are just, 2-3 stories tall, townhouse typology. And the site, interestingly, was underdeveloped forever. For a very long time, because it was undevelopable or did not make sense to develop it because it was too small of it. It's about 7,000 square feet total. So it existed in this incredibly dense Boston area as a parking lot for 20 cars for many decades. And those are the cute little 2-story townhouses of the Bay Village neighborhood. So we were contacted by the developer and asked, could we design a building that could really mediate the scale that the neighbors would enjoy and welcome versus protest and not welcome, and still pencil out for the developer, fill in this missing tooth in the city. So we did this kind of inventory because many of the kind of new towers, 20-story buildings tend to be thinner in material and curtain wall, lots of glass. But we did an inventory of the materials in the neighborhood, and we thought about how do we break up the scale of the building because it's 20 stories, but how do we make it more human in scale? And we did a set of studies that tried to keep breaking up the mass. We also learn from that inventory of the materials in the neighborhood that range from brick to limestone to kind of fluted columns and this kind of rich texture. So we cast a series of flutes out of plaster one day, and we're saying, could we create a kind of thickness that has the qualities of some of these historic materials used in the neighborhood, give it light and shadow. Then we milled that out of this limestone to get this kind of fluted quality. This was one of our first concept models. This was the first rendering. And then we thought, like, well, maybe we could accomplish this, by creating a series of 3 or 4 molds. We thought the molds were really going to be expensive, so we started to limit our thinking about, okay, fewer molds, more affordable, more possible. But then we learned, actually, it has nothing, like, we can make as many molds as we want. The cost was really driven by the crane, the time the crane would be on site. So what we learned is the most efficient thing we could do is actually do multi-story precast panels so that we minimize the number of picks the crane needs in order to assemble the building. So we work with a local precast manufacturer on designing these multi-story panels. So they're like literally just a few miles from Boston to work with these kind of geometries. And then you can see the multi-story panels going up on site. And there are only 8 units per floor, which seems, again, because it's such a tiny, tiny footprint. But the other thing about Boston is there's a 17% affordability requirement for every new residential construction, multifamily. And so there's an encouragement that it's more than 17%. So many developers are doing 20% affordable. But one thing that I love about this project was not intended, but actually came out of a negotiation with the neighbors and made the project much better. So you can see, like, there's no room for loading, and loading's so important. We originally had the loading and the mechanical on the back side of the building, which is Shamet Street, which faced these cute little townhouses. And so we were a very bad neighbor. And what we heard from the neighbors is they didn't want the loading and the back of the building to be the back. They wanted the back to be the front, which made total sense. So the innovation was actually to create 2 townhouses that would have stoops and front porches that would also face Shamet Street. So it's a very interesting unit because it's a duplex. So you can get at it from an elevator from the lobby on the main street or the stoop front door on Shamet Street. So these are some of the more recent photographs just recently completed. And the contrast, I love the Hancock building. Beautiful building, all glass, but I think we also need to think about building in ways that are not all glass. We're also thinking a lot about the neighborhood in the city and neighborhood institutions. I think we all saw a lot of things lost during the pandemic. A lot of favorite restaurants closed down. One of the favorite institutions in this area called Brookline in Boston is the Coolidge Corner movie theater. It's an Art Deco theater, plays kind of films that are more small scale. It's not a big blockbuster kind of venue. And the Coolidge has thrived in this funky Art Deco building for many years, and it's actually outgrown its space. So we were asked, I guess we're like the backside architects. We were asked to do an addition on the backside of this building. Here's a plan of the scale. So everything dark gray is the existing building. And we were asked to add 2 theaters and a community room on the backside. So everything your right of that red dotted line is the addition and the existing Art Deco building. So our design needed to complement the kind of historic Art Deco motif, needed to turn the backside into a front, and needed to provide 2 theaters, very small actually, scale theaters compared to like a multiplex, and then a community room on the top floor for the neighborhood. So this is the kind of entry. So the backside becomes the new lobby and ticketing, and we wanted to make sure it creates a very good connection to the historic deco part, which is on your left. Then there's a theater on the next floor, and we wanted each theater to be a super intense color. So there's a red theater, and then if you go up, there's a blue theater, and then there's a nice community room on the with a roof terrace, not dissimilar from here, but without the beautiful, beautiful lake. But one of the questions that the Coolidge Corner Theater asked us is, how do you do Art Deco today? And how would you translate Art Deco? Art Deco is amazing. Such beautiful tactility to the way they would use the kind of bricks and materials, the kind of celebration of a kind of human scaled technology. So we developed a kind of idea around a facade that would use the same kind of bricks as used in the front of the Coolidge Corner, but undulate them almost like a large curtain. And then this is a recent construction shot of that brickwork. And these are all hand-laid bricks by amazing masons. And this gives you a sense of that texture. And this should be finished construction in a 2 months, 3 months, they say. Looks like it needs a few more months, though. Okay, I have 2 last projects to share, and they're really about thinking about memory and materials over time. And I think, you know, sometimes we build for, 30 years, sometimes we build for 100 years, but I do think like we're much more cognizant now that our buildings last for a long time. And I was talking to an architect, local architect today, who said, if it's a bad building or a good building, it doesn't matter, it lasts a long time. We need to remember that the way we build has an impact. So this project is really born out of a tragedy. This is the Boston Marathon bombing. And that tragedy was not contained. It impacted the whole city, the victims of that bombing, their lives, their families, but it also extended out to MIT's campus and Cambridge and Watertown. So when the Tsarnaev brothers were hiding and running, they ran through MIT, and I was a faculty member at MIT at the time. And when they were on the MIT campus, they shot and killed a very young campus police officer named Sean Collier. And this was the first shooting, first act of terrorism on campus. It was very hard. It hit the community very, very hard. And this was a kind of informal memorial that just happened spontaneously. And I was asked to take this community input around what the Collier Memorial should be at MIT and synthesize that into a physical memorial on campus. I heard from many members of the community that it was really important to have the American flag on the site and many American flags on the site. We heard from those who knew him closely that he loved to hike, and maybe a cairn, like a stacking of rocks, would be the appropriate way to honor him. And then we kept hearing this term, Boston strong, MIT strong, and 179 was his batch number. So MIT solicited ideas from the community. There was a document over 100 pages of different ideas. And I was asked to work with a committee that had colleagues, some of his friends, some fellow officers, some administrators, to develop an idea that could synthesize all these ideas. So the concept emerged that maybe a flag might not be the appropriate marker for this memorial, but something that could be maybe seen as a star. This is a star that's carved into the wall in Langley, or it could have some resonance with MIT's motto of hand in mind, the hand of doing, mens et manus. So this memorial is a 5-pointed figure, which has a hole carved out of it, like a absence or a bullion, and that boulder or shape is kind of removed. That makes the 5-pointed figure not an obstruction, but something you could pass through and be sheltered under. This is the memorial from above, but it's also a kind of became a research project in a very MIT way that came out of the concept of strength is not brute force, but strength actually comes from many individual things sharing the burden or sharing the load. So the idea of the arch, where every brick supports the other brick, and the research around how to build such a compressive structure. So really you could see the memorial not only as a 5-pointed figure, but actually 5 half arches that are leaning into each other and supporting each other. You could also see it as a kind of shallow dome made out of 33 unique blocks of solid granite that support each other purely through physics and geometry. So there is this, 140-ton mass above you of solid stone suspended in air through physics and geometry. Center block that would be the pin that would hold this all together. Just get a sense of the scale of it. And what was really important about this is that if there was any imperfection, so it is theoretically possible to build this as a fully compressive structure, but if it's, a 1/16 of an inch off, it could fail. Or if it's 1/2 inch off in the joint, the top could fall. So it had to be perfect. So, we're at MIT, we have tons of robots and tools. We're like, it can be perfect. We can model it perfectly in the computer and it can be fabricated by robots perfectly. And then our fabricator said, but the wearing of the saw against the stone when you're sawing it is creating something you cannot calculate because the diameter of the saw is shrinking while it's carving those massive blocks of stone. So we're like, well. So what we did was we, as we fabricated each block, it was measured, it was scanned, and then we would adjust the 3D model of the next block so that it would be a perfect fit. And we did this for every single block, and 3 blocks at a time would come essentially to MIT on a truck. The other thing we did was, because it was a test, it was a theory. It was not provable because no one has done it before. So we had to build it so it was provable that this could work fully in compression. So we built the vault backwards, essentially, and that we built it on scaffolds from the center out, so we could shed any tolerance difference outward into the legs. We also inserted a series of stainless steel pins in the critical areas where the engineers had concern. But we said we would not put the pins into action, or we had the ability to not put the pins into action if we did not want to. So the pins are there, but they only go into action when you pour in the grout. So we put strain gauges at every joint. We put that scaffold on these mega scales that were measuring the tonnage of weight supported. And then at the top, we slowly release the scaffold. 1/2 turn at a time, so 1 millimeter at a time, while measuring what the scales were saying. And this happened over 5 hours of incremental lowering of the scaffolds so that the forces of the blocks, that weight would transfer from one block to the next block to the next block as slowly as possible, so that we wouldn't get like a shift in any of the stone, which would create a severe problem. And we were successful. This is our amazing crew. And I think one of the really amazing special moments is the gentleman that's not wearing a vest. His name is Rob, and he is the brother of Sean Collier. And he was the project manager for this project. So this project was something that was very special and above and beyond, I think, for everyone who worked on. But the other thing the memorial does is it kind of frames these incredible views. And when you're under this dome, it feels very protected and quiet and somber. But when you're around, you feel like this is part of your environment, and it becomes like a series of rock gardens. And when then you're further out, you understand this memorial and the sacrifice and the loss and the absence of Sean Collier. The last project I'm going to share is the Memorial to Enslaved Laborers at UVA. And for me, it helps me think about the role of the institution, like the role of UVA, the role of Stanford, the role of Yale, the role of MIT, the role of Cornell in building a better future. So we all know Thomas Jefferson, third president of the United States, signer of the Declaration of Independence, founder of the University of Virginia, also called the architect of the University of Virginia, and the owner of 600 enslaved people in his lifetime. If you look at the kind of signage around the history of the University of Virginia, until very recently, there was no mention anywhere of the enslaved people who built and maintained the university. And UVA created this small plaque that's underfoot near the rotunda as the first recognition and acknowledgement of the enslaved laborers. But this small plaque had the unintended consequence of creating outrage among the students, faculty, the community, because it really minimized the history of slavery at the university. And then again, it did not do what this acknowledgement needed to do for the community. So the students formed an organization called the Memorial to Enslaved Laborers to bring more recognition to this history. Faculty and the community organized an action group called You Care. And this is the student, Ishraga. who founded the student group called the Memorial to Enslaved Laborers in 2010. Then the university uncovered these unmarked graves of the enslaved, and the president formed an official commission on slavery and the university that was comprised of faculty and experts, historians, and students. So this is one of the oldest prints. It's a Tanner Beauvais print. And if you look in the corner, you will find the first representation of an enslaved person caring for a child. If you look around the campus, you might even find bricks with the kind of imprint, fingerprint of the enslaved young boys who made each of these bricks by hand. This one is from Monticello. And then if you look at the architecture of the campus, you will see the beautiful historic lawn with the rotunda terminating it. But you'll see the pavilions have an interesting section where it has a kind of walkout lower level, which were the yards, the work yards, where the enslaved did backbreaking labor to maintain the university. So our team, we had an incredible team. Our design team included historian and designer, architect Mabel Wilson, Frank Dukes, who started UCARE, whose area of expertise is environment and negotiation, landscape architect, which was critical, Greg Bleem, and the artists Eto Otitigbe, along with myself and my partner, Eric. So we said in order to design this project, we really needed to design the process. So we had a 6-month engagement process. The university did not give us a site, did not give us a budget, very unusual. We had to find the site. We had to explore with the community where the right place was for the memorial. So we explored multiple sites. And then what was important about this 6-month process was it really allowed everyone to participate in the design process, because these would be these tests. We would visualize these tests, and then we would hear from the community what was working and what was not working. And we looked at sites on the lawn, and everything from very ephemeral proposals like planting crocus flowers in the green lawn and just letting them bloom annually once a year, to like paths, to physical artifacts. But what we heard from the community through the process was the memorial needed to be a space and a place for gathering, not only to recognize the painful history and honor the ancestors, but to also be a place and space for advancing racial justice today. And I think this moment where everyone was gathered in a circle on the triangle of grass was really important. The idea of this ring shout, this ritualistic dance, have life and joy, and we heard that from the community and the descendant community as well, that it also needed to celebrate the resilience and the humanity of the enslaved, and not just the pain. So the memorial is very simple in form. It frames a gathering space. It's made out of a series of rings. It's 80 feet in diameter, which is the same diameter as the rotunda, but instead of being solid and enclosed, it's actually conical in section and open to the sky and nestled into the landscape, so that it is very shallow when you enter. And then as you walk around it, because the ground slopes ever so slightly down and the wall moves ever so slightly up, at some point you lose the horizon line, and then you're kind of face to face with the inclined wall. We draw lots of things at full scale to understand the kind of section. So this is when you're inside the memorial versus on the outside of the memorial, and being able to see above and across. a memorial. So this is the ring. You can go clockwise or counterclockwise. This shows the kind of molded texture, the rough texture on the exterior versus the smooth texture on the interior. And this is something Eto Otutigbe really wanted to create a material resonance with these kind of gravestones of the period. And then also we heard from the community, they really wanted a form of representation of an enslaved person, an actual enslaved ancestor in the memorial. So Isabella Gibbons was a matriarch. She was an enslaved woman who was freed and stayed in the community and became a teacher. And so we wanted to carve, she's also the only person we have a record of a first, last name, a photograph, and writing in her own words of her experience as an enslaved woman. So we wanted to create her eyes at a kind of colossal scale on the memorial, but in a way that you would only see it from a kind of certain vantage point. So her eyes are like she's the watcher and the witness of this site. The other challenge we had was, how do you acknowledge and honor approximately 4,000 enslaved people for whom you might not have their name? They might be records that are very meticulous about their labor, but not about their humanity. So we know out of the approximately 4,000 enslaved, only about 900 names were recorded, or individuals have some form of recording. 577, a full or partial name, and many for whom we just have a kinship or an occupation. So we created what we call 4,000 memory marks into the granite. Those memory marks, when we have a name, we carve it above that memory mark. When we have an occupation or a skill or a kinship, we carve that in as well. And then you can see these memory marks have a crescent kind of geometry that works in plan and section. So it cuts a little deeper, like a gash. And when it rains, it holds the water just a little bit longer so that the surface around dries faster than the water that's held in those cuts. And then those cry or bleed down the memorial. And the most meaningful part of this project was getting to know the descendants who took real ownership of this memorial. It built community, the designing and building of this memorial. And I've been to this site when Colleen or Datisa are giving their own tour to people who want to know more about the memorial. The other really important thing that UVA did was hire a genealogist, because the idea was it's a living memorial that we would learn more, and that names would be discovered, and the names would be carved in at a later date. The memorial was still like fenced in, but after the killing of George Floyd, people just moved into the memorial, and it, one person, 5 people, 20 people, until, the white coats for Black Lives remembrance of George Floyd happened on site spontaneously. And this is in the words of Colin Cotter: power is not its language, closure is not its goal. Active, additive remembrance is this what distinguishes a memorial from a monument? A monument says, I am truth, I am history, full stop. A memorial says, or can say, I turn grief for the past into change for the present, and I always will. I think we can't change the past, but we can learn from it. And so this was a really beautiful moment where the Hearn family gathered to see their ancestor's name carved in because it was discovered during the process and after the memorial was constructed. So I think institutions have a really important role to play in the kind of building of the future and society. We're continuing to work with the University of Virginia, currently on the Institute for Democracy. And it's such a privilege to work with and for academic institutions that are asking really important questions today and will last long into the future. And What's the Matter is the first chapter in our recent book called Verify and Field, which looks at about 10 years and many questions that we as architects are asking today. And I think I wanted to end with Bucky Fuller with this beautiful, beautiful quote. When he designed this kind of full-scale interactive game in the late 60s, might be early 70s. But he said, to make the world work for 100% of humanity in the shortest time possible through spontaneous cooperation without ecological offense or the disadvantage of anyone. If we could live up to this, we would be in good shape. Thank you.
Sure. Can we just get 2 questions? Sorry, because we ran a little bit long. Just raise your hand if you have a question from Meejin.
Yeah, I'm sorry, I went a little long. I never know which project to take out. So if you have a suggestion. Yes,
Project where you use core tin in the brick.
yes.
How do you keep the core tin from staining the brick?
Oh, it stains the brick. Yeah, so I think it just keeps streaking. And I think, for us, like, I think we can't fight materials. You have to just accept the material. So we plan for that, and there's gravel, and the streaking goes into the gravel at the base. But I think it gives it a real patina.
Any earthquakes in Boston?
No, but I didn't show the picture, but a car drove into the memorial at like very fast speed, not intentionally, but someone had a stroke and the car just kept going, and it was high impact and nothing moved. So I think, yeah, and the gentleman was okay. So yeah.
Good, that's a happy ending.
That's it. Well, thank you all so much.
All right, thank you so much.
No. I was trying to it's hard on the memorials to go faster, but I was eyeing it. I was like, I can go faster.
I'm glad you did it. Glad you did it. I know those projects. It was still very effective.